Okay, and this problem is problem number 3 from page 71 of the textbook. It's going to be a very simple elimination, but it has a lot of steps, so get ready. Again, we have 3 equations, and something that's nice about these equations is they're already nicely lined up for us. So we've got our blue equation, our yellow equation, and our red equation. And when we look at the top here, we should see that with blue and yellow, there is a very easy elimination. What is the easy elimination if we choose to go with blue and yellow? X is an easy elimination if we choose blue and yellow. Now, in this example, we actually choose yellow and red because yellow and red have a very easy elimination also. And what is that one?
Z.
Z. So we see that if we add the yellow and the red down, we will end up with 1z plus negative 1z equals 0z, and that's what we mean by eliminate. Jackie. This is a 9. Is that what you're asking about? That's a 9, yeah. Kind of looks like a person with no arms and no legs. It's a 9. It's not a person with his head tilted. Okay. So we add down and we see that negative 1x plus 2x equals 1x. We see that 2y plus 3y gets us to 5y. As we said, the reason we're doing this is to eliminate z, and then we add down 2 plus 9 equals 11. And we will call this sort of the yellow and red equation. It is a simplified version of adding these two equations together where we eliminated the variable z. Please don't yawn out loud. That kills the vibe. You're on video. So we chose the yellow and red equation, which means that now we must use a different equation. We must use the blue equation, and now things are getting trickier. We must use the blue equation, and again we must go after z. So our blue equation says x plus y minus 2z equals 5. So now we need to eliminate with the negative 2z. Again, we already used yellow and red. We need to use all 3 equations. So now we must use the blue. And in this example, I chose to use the yellow equation because the sign of z is already different on the blue and the yellow. So now I see that right now I have negative 2z plus 1z, and that will not eliminate. But if I multiply this second equation by 2, remembering to distribute to every term, then I will get positive 2z in my new version of the yellow, and then I will get elimination. So now I add the blue with this new version of the yellow, and I say x plus negative 2x gives me negative 1x. They still have x's. We say y plus 4y gets us to 5y. And now we get this elimination. Negative 2z plus 2z gets us to 0z. Z disappears. And then over here at the end, 5 plus 4 equals 9. So now we have 2 new equations. They both have yellow. This one has red. This one has blue. So now we have used all 3 equations. We have eliminated z. And now we have an equation with, we have 2 equations that only have 2 unknowns, x and y and x and y. Now this next step comes out way too easy. On other questions it's going to be more difficult, but when we take the yellow and blue and match it up with the yellow and red, which is what we have, we get really easy elimination again. Because 1x plus negative 1x eliminates the x. 5y plus 5y gets us to 10y. 11 plus 9 gets us to 20, and we have 10y equals 20. We divide both sides by 10 and get y equal 2. Now we know what y is. Sorry about the move on the... Here we go. We know what y is. And now we're going to go to an equation where we have y and only one other variable. We made that equation. It is the yellow and red equation. Or it could have been the yellow and blue equation, but here we choose the yellow and red. Because it just has 1x plus 5y equals 11, where we already know y equals 2. So we'll say 1x plus 5 times y, 5 times 2, equals 11. And easy simplification shows us that x must equal 1. So now we know y is 2, and we know x is 1. Yes? I'm not going to move it up anymore because I got to turn the page and finish here. I'm sorry that I can't accommodate that right this second. Okay, Jackie, I got to turn the page. You'll get it in a minute, don't worry. So now we simply plug in x and y. This is going into the blue equation from the beginning of the problem, where we know that x is 1, we know that y is 2, and we find the unknown z. This is pretty self-explanatory. Taking it all the way down to z equal negative 1, which gives us our x, y, and z, and we report that answer as what we call an ordered triple. X, comma, y, comma, z, in parentheses, 1, 2, negative 1.